Okay, recall from yesterday our two special right triangles. We have a 45, 45, 90, or a nice isosceles right triangle. Ratio of sides is 1, 1, root 2, or you could think of it as x root 2 if you want to. And the other special right triangle is our 30, 60, 90. Opposite the 30 is going to be the shortest side of 1. Opposite the 60 is going to be the middle side of root 3. And then the hypotenuse of a 30, 60, 90 is always going to be equal to 2. So say here that we're being asked to find the sine of 30 degrees. Now, if you remember from last week, anytime we deal with similar triangles whose angles are congruent and sides are proportional, they're always going to have the same ratio of sides. So it doesn't matter what 45, 45, 90 I'm working with or what 30, 60, 90 I'm working with. I can blow these up 1,000,000 times or I can make them 100 times smaller. The ratio of sides are always going to be the same. So anytime we're asked to find the sine of 30 degrees, we can go back to our basic 30, 60, 90 and find the corresponding ratio of sides. So if we're finding the sine of 30, 30 degrees would be our reference angle, and we know that sine is the opposite over the hypotenuse. So what is 30 degrees opposite? That would be 1. What is 30 degrees hypotenuse? That would be 2. So the sine of 30 degrees is equal to 1/2. Grab your calculator, let's check it. So go to mode, make sure that you are in degree mode, which we are. Find your sine button, type in 30 degrees. What are we getting for the sine of 30 degrees? That's equal to 1/2. Okay, let's look at another example. Let's find the cosine of 45 degrees. So now we need to move to our 45, 45, 90. It doesn't matter which one you make theta because they're both 45 degrees. So let's say I let this one be my theta. Cosine is the adjacent over the hypotenuse. What's the hypotenuse? Root 2. We've rationalized that by multiplying by root 2 over 2. And we're going to get the square root of 2 over 2 for the cosine of 45 degrees. So then I check it. The cosine of 45 degrees is equal to about 0.71. So check the square root of 2 over 2. Make sure it's the same value, which it is. Let's do another example here. Let's say that we want to find the cotangent of 60 degrees. Well, cotangent is the reciprocal of tangent. We know tangent is the opposite over the adjacent, which means that cotangent is going to be the adjacent over the opposite. So 60 degrees is my theta. I need the adjacent, that's going to be 1. That's going to be divided by the opposite, which is root 3. I'm going to multiply to get rid of the radical in the denominator, and we're looking at root 3 over 3. Now, if I want to check this guy in my calculator, notice we do not have a tangent button. So in order to check this, we're going to have to go back and relate cotangent to tangent. We know that the cotangent of 60 degrees is the same thing as 1 over the tangent of 60 degrees, right? So through reciprocals, which we had talked about last week, we get the same relationship. So if we enter this guy in as 1 divided by the tangent of 60 degrees, we get about 0.58. Let's check the square root of 3 over 3, and that's also giving us the same value. So you're going to need to relate the reciprocals here to their original trig function. So cotangent is 1 over tangent, secant is 1 over cosine, and cosecant is 1 over sine. So let's do one more example. Let's say that we're looking for, I don't know, let's do the cosecant of pi over 4. Now notice that's a little different here. We were working with degrees, degrees, degrees. Ooh, now Mrs. Miller's giving you a radian. So the first thing that we need to do is take pi over 4 and we're going to convert it to degrees. So in order to convert it to degrees, we're going to multiply by 180 degrees over pi. We talked about this last week. So the pi's are going to cancel. We're left with 180 degrees over 4, which means that we're really dealing with a 45 degree angle. So here I'm really asking you to find the cosecant of 45 degrees. So then we go back to our 45-degree angle. We know that cosecant is going to be the hypotenuse over the opposite. It's the reciprocal of sine. So the hypotenuse is root 2. The opposite is 1. So the cosecant of pi over 4 is equal to the square root of 2. Now go to your mode. We need to put ourselves in radian mode since our angle was expressed in radians. Go back to your home screen. Cosecant of pi over 4 is going to be the same thing as 1 over the sine of pi over 4. So if we type in 1 over the sine of pi over 4, we're getting approximately 1.41. Check the square root of 2. Is it equal to 1.41? Yes, it is. So we're going to have to start checking our angles. Are we in degrees? Are we in radians? And in terms of finding the trig function values of those angles, we're going back and we're using our two special right triangles.